Differentiation. Right, so you guys have learned about the rules of differentiation, where the history begin from the limit first. Yeah, so differentiation starting from the limit. And the differentiation rules, I will remind you for the important rules here. First of all, if there is a function of k, yeah, where k is a constanta, and the first derivative will be 0. And if a function is the exponential x with exponential n, then the first derivative would be n times x power n minus 1. And if there is an exponential function with a k beside that as a coefficient, then the first derivative will be, here you see that this is still the coefficient, and then the exponential will go down, and it will be multiplied with the coefficient, and then the x here, the exponential of x will be subtracted with 1. So k times n times x power n minus 1. And also you see here the additional and subtraction function, and also multiplication of two functions, and also division of two functions. Yeah, first of all, for the additional and the subtraction, you see here that fx is equal with g function of x plus or minus h function of x. Then the first derivative will be the first derivative of g plus or minus the first derivative of h. How to apply the first derivative of g and h? That is the rules from the previous three rules that I have mentioned before. And if here is the multiplication that we met, g function of x times h function of x, then the first derivative of f will be the first derivative of g times h function plus g function times first derivative of h. I know that you have learned that also in your high school, for this kind of the rules, right? Okay, and if I will write down for so that you will remember of your things in at high school. So if f(x) and x will be g accent h times g h accent, right? And for the division here, so you learn this as a y equal with u over v, and that will be y accent is u accent v minus v accent u over v quadrat. So this is the same, yeah. G accent times h function minus gx times h accent over h quadrat. Okay. Okay, now I want to teach you another thing about the writing of the derivative function. So you see that the derivative function that I have write down before is like using the accent, right? So if y equal with fx, then the first derivative will be symbolized as y accent or f accent x, correct? But now we have to change that into another level of writing. So for the first derivative is that you need to write it down as y accent will be dy dx. Why is that? It means that we derive the function of y to x. Okay? Or fx and x will be dfx dx. Now, and then the second derivative is y double xn, and you must write that as d quadrat y dx quadrat, or if you met f double xn x, then you must write it as d quadrat f x over dx. Why is that? Because later on we will deal with two independent variables. Instead of only one variable like this, we only deal with y, right? So now we only, we deal only with one independent variable, which is x, and later on we will talking about the function of y with two independent variables like this. So if you have here is y as a function of two independent variables, x and z. So if you derive that, the first derivative of y will be dy is equal with dy dx dx plus dy dz dz. Okay, now I will change this into not a really straight d, but it is a bit curve of d, and I call that as a dou. Because of what? We have to derive one by one with one independent variable. So first of all, you need to derive that only with x. So I will write down again here. Okay, so you cannot derive all of the y function directly both with with x and z, but you need to derive that one by one. Okay, so that's why it is important now that we have to distinguish the writing of the derivative, and it is very important if we met a function on with more than one independent variables. So the first derivative of y is this, which consists of dou y dou x and dou y dou z. So you have to derive that one by one. For example, okay, if it is y equal with x quadrat plus 3z, so the first derivative of y will be consists of you have to derive that first with x. Yeah, so x quadrat here is 2x, but 3z here you don't see any kind of x next to the 3 and z. Yeah, so that it means z is just a constanta because it has no x in here. So the derivation of 3z 2x is 0. Like when you derive y is 3, dy dx is just 0. So equal with z here, dy dx is also 0 because it has no x in here. Yeah? And the other thing is if dy dou y dou z over here, so you see in here there is no z at all, so it's just 0. The derivation to z is only 0 plus 3z. Derive that to z, it give you only 3. So that's why now I need you to write any kind of derivative using this method using dy dx. So we need to see these things as the independent variables that we want to derive with the original function of y. Okay. Now we go to another differentiation rules. Okay, first of all, y is f u and u is gx. So I'll write it down again here. Say that there is a y with a function of u and also u as a function of x, and the question will be what is dy dx here. So you see here that y has only one independent variable of u. There is no x inside that, but u itself is a function of x. So how do you want to solve this? Using the chain rules here, yeah, you have to see that as a multiplication of if you want to find the dy dx, then you need to see that as the multiplication of dy du. So the derivation of y function u, multiply that with du dx. So if it is the original algebra, yeah, you see that du here as the denominator and du here as the denominator, then it can be vanished with each other. So it becomes dy dx. So you see that it can be like this. So this is what we say with chain rules. dy du here, you can derive that from the y as f, the function of u, and also the derivative of u against x. Okay. Next is, all right. So this is a function of a function. No, sorry, the exponential function, right? So y here is fx power n. Now, so this is also the things that we apply the chain rule. If you see here that this only just n times function of x power n minus 1 times the first derivative of f. Kind of complicated, right? But if you understand about the chain rules, then you can say no. I mean, you can change the function of x here, where it might complicate it, with just one symbol. Say that this is an s. You see? So y is s power n. So that is a very simple to see, right? Now you know that dy ds here, if you derive that to s, then it become n times s power n minus 1. Then how it become dy dx then? Again, it's just like the chain rule over there. Dy dx here is n as n minus 1. Sorry. So that will be, wait a minute. That is dy du dy, well, let me see here. Dy dx will be dy ds over ds dx. So you have the function of dy ds over here, and now since that you say that s now is fx, so you have another function. S is a function of x here, So then the first derivative of ds dx will be df dx, right? Okay, then you just put down this thing here as dy ds and here as ds dx. Work on that. Okay. Well, next is okay, first of all I will erase this. Right, so now we go to the fourth. Oh, sorry, to the third. Yeah. Third is if y equal with a exponential x, then the dy dx, the first derivative, will be the same. Okay? So that's for third. And then for the fourth, if y is a constanta with power of function x, then the first derivative will be bx ln b. Okay, so do memorize these things. And the fifth is if y equal with b function of x, then the first derivative of that will be the same as this, but now instead of x, you change the x with function x here, and then again ln b. But since you have function of x here, it should be derived like this. Oh, I will arrange that through this thing. B function of x times df dx times ln b. Okay. Next, the sixth, ln x. If there is a function of ln x, y is ln x, then the first derivative of y is 1 over x. Okay. And the seventh is if y is ln function of x, then the dy dx here is df dx over function of x. Okay, I will go down with some example. Okay, so here are the examples. I need you to do these things, yeah, but I will give you some example before you do this. Right. My example here is, so this is not example actually, exercises. Exercises. Okay, so you see here 1, 2, 3, 4, 5, 6, 7. Okay, I will start with kind of like number 8. Well, with 4 and 8, yeah. Say that 5x 1/3. Okay, so the first derivative of that is 5 times 1/3 x 1 minus 1/3. So that will be 5/3 x 1 minus 1/3 is 2/3. So that's it. So what if I ask, yeah? What if I ask, what is dy dz? Can you see z here? No. Yeah, so if there is no variables that will be derived here, no z in here, so you consider the x here as a constanta, so it is 0. Period. Okay. And now we'll take an example like number 8. So say here 2 y is equal with again 5x now minus 2/3 minus 3x. Okay, so what is it now? I will make the things with a square root here. No, not square root actually, root function, yeah, with the exponential. So I will write down again here minus 2/3 minus x power what? This is 1. And how you change this? The square, the root, I mean. It is, because it is 3 here, so it means that the power here would be divided with 3. Okay, so then the first derivative of that is 5 times minus 2/3 x minus 2/3 minus 1, big minus x 1/3 minus 1. So I'll go here because I have no space anymore. dy dx will be 5 times minus 2/3 is minus 10/3, and the x will be minus 2/3 minus 1 is minus 5/3 minus x 1/3 minus 1 is minus 2/3. So that's it. Okay. Okay, now I'll try an example of number 2, yeah. So that is multiplication of two function. Y is x5 plus 4x times 3x plus 2, yeah. So through the rule that I have mentioned in the beginning, that for the multiplication of two function will be the same. This is the same as what you have learned at your school. Y accent is u accent v plus v accent u. So this is, we can say that this is as a u and this is a v. Okay, all of these things. Now u is the x5 plus 4x and v is 3x plus 2. So the du dx here is dx, okay, is x power 5 is 5x4 plus 4x will be 4, and here is dv dx. So here 3x will be derived as 3 and 2 is 0, so only this. Right now dy dx is u action, means du dx times v plus dv dx times u. So du dx is 5x4 plus 4 times v, and v is 3x plus 2 plus dv dx is 3 times u. U is x 5 plus 4x. Well, I think it's done, yeah. Well, it's enough until here, or well, you can open up all of these brackets, like 5x4 times, well, that's kind of long, yeah. I mean, you have to do it by yourself, so make a insert all of the I mean, open the brackets and then multiply both this and also this, or you can stop here, fine, yeah. Okay, and now I will try like number 6. Okay, so say y is 5x3 minus 2, okay, with a 4, okay. Now how to work on this? Say that this is an s, so I have a function of s 5x3 minus 2. Okay, now we want to find what the dy dx is. So dy dx equal with dy ds. Remember that I said about chain rule? ds dx. Okay, now this become s over 4. Okay, so since y is s with power 4, and then the derivative of y should be with the s, it will be like this. 4 goes to the left, s power 3, yeah, and the other one is s equal with 5x power 3 minus 2, and the derivative of s will be against x. It become 5 times 3x quadrat, right? And minus 2 derived with x is 0, so this is 15x quadrat. Now we go to here again, back here again. So dy dx is dy over ds is, what is that again? 4s power 3 times ds dx is 15 here, yeah, x quadrat. Now you see there are 2 independent variables in here, s and x, and we want to find that dy should be only depend on x. Then what we should do is that to change again the s with this function. So 4 is 5x3 minus 2 power 3 here, power 3 there, times 15 15x quadrat The 15 go to the front, so 15 times 4 is 60. X squared goes to the front too, and this will be like this. So that is the dy dx, and this is the example of chain rule. Now I'll try to go to this kind of exercise. We have to find the second derivative. Well, I will try number C then. Okay, I'll try to make my own example again. I will have 2, so this is the usual one. X third minus 4x squared minus 5 of 5 plus 5x, say 2/3 here. Okay, now the first derivative is dy dx. Derive this 3x squared minus 4, 2 goes to the left here, so it will become 8 over x times x plus 5 times 2/3 x 2/3 minus 1. Right, I will change this first. Let me see, so that you can follow me well. 4, 2 goes here, and this 2 minus 1. Okay, so this will be 3x squared minus 8x plus 5 times 2 is 10 over 3. X 2 over 3 minus 1 is minus 1/3. So that is dy dx, the first derivative. Now what about the second derivative? The second derivative is the first derivative of the first derivative. So you derive the first derivative. So you derive this first derivative, that is second derivative. Okay, now goes here. Okay, try this. 3x squared, first derivation is 3 times 2x, 2 minus 1, minus 8x, so this is 8 times 1, because this is power 1, right? X 1 minus 1 plus 10/3 minus 1/3 x minus 1/3 minus 1. So then this will be 6x minus 8x power 0 is 1 plus, oh no, minus 10/3 times minus 1/3 is 10 over 9. So this x minus 1/3 minus 1 is minus 4/3. So this is the second derivative. Okay, so you have to find the first derivative first and then derive it again. Okay, so this is the end of the first part.